Now we're going to look at some arithmetic sequences. So the first thing we need to do is try to find the pattern. So I know to get from 2 to 5, I add 3. From 5 to 8, I add 3. From 8 to 11, I add 3. And from 11 to 14, I have to add 3. So my pattern is I am adding 3. Okay? How we can find this using what we just took notes on is that next to previous. So you're going to take your next term, which would be 5, minus the term before it, which would be 2, and 5 minus 2 is 3. Check it again. The next term is 8, minus the previous term is 5. 8 minus 5 is 3. Then you would have 14 minus 11, which equals 3. We defined our recursive formula on our previous page, so please refer to your purple sheet. And that tells us that we have a sub 1 equaling 2. A sub n equals a sub n minus 1 plus 3. Your previous term plus your common difference of 3. We're going to skip the next column and we're going to go on to the 0 term. So to find the 0 term, you're going to take your first term, which we know is 2 in our sequence, and we're going to minus our common difference, which is 3. So 2 minus 3, your 0 term would be negative 1. So that is when a sub 0 is equal to negative 1. So n is equal to 0. Your explicit function, our equation for that is a sub n equals a sub 1 plus n minus 1 times d. So a sub n, the first term in your sequence is 2. Remember, negative 1 is the 0 term. Plus n minus 1 times your common difference is 3. After the explicit, we're going to go back to the simplified expression, and that's telling us to distribute. So that means we're going to take our negative 3 and we're going to multiply it by our parentheses. So we would have a sub n equaling our 2, which is our first term, plus 3 times n would be 3n, and 3 times negative 1 would be negative 3. Combine like terms, we're going to combine our numbers. A sub n would equal 2 minus 3 would be negative 1 plus 3n. So here is your 0 term, and here is your common difference. Okay, let's look at another one. We have 55, 50, 45, 40. So how do we get from one to the other? 55 to 50, I'm taking away 5. 50 to 45, I'm taking away 5. And 45 to 40, I'm taking away 5. So my pattern is that I am minusing 5 from each term. To find this pattern, to see if it's true, we do our next minus previous. So 50 is my next term, minus 55 would be negative 5. 45 is my next term, minus my previous term, which is 50, and I have negative 5. And then lastly, 40 minus 45 equals negative 5. You have to check all of your numbers that are given to you in your sequence to make sure that the pattern holds true for all of them. So my recursive formula would tell me that a sub 1 is equal to 55. A sub n equals a sub n minus 1 minus 5. So my previous term minus that common difference. So let's look to see how we can find our 0 term. Our 0 term is our first term in the sequence, which is 55. So here's your first. And then you're going to minus that common difference, would be minusing a negative 5. Two negatives make a positive, so 55 plus 5 makes 60. Now our explicit formula. That is a sub n equaling a sub 1 plus n minus 1 times d. So a sub n, your first term in your sequence, is 55 plus n minus 1 times your common difference of negative 5. Now let's go to simplify that. Again, a sub n would equal 55. Now if we distribute, that means we're taking this negative 5 and we're multiplying it by our two terms in parentheses. So negative 5 times n would be negative 5n. And negative 5 times negative 1 would make a positive 5 because a negative times a negative is a positive. Combine like terms. A sub n would equal 55 plus 5 would be 60 minus 5n. Again, when we simplify the explicit function, you are given your zero term and your common difference. Okay, let's look at another one. So here, for this one, to get to 1 to 2, we add 1. But 2 to 4, we have to add 2. And 4 to 9, we're adding 5. And 9 to 16, we're adding 7. So there is no pattern. If there is no pattern, then you can't find the next to previous. You have no recursive. You have no zero term, and you have no explicit function. So if there is no pattern, you cannot find the recursive or the explicit. Okay, let's look at another one. To get from 0.5 to 0, I would take away 0.5. From 0 to negative 0.5, I would take away 0.5, and negative 0.5 to negative 1, I would take away 0.5, or a half. So my pattern is I'm minusing 0.5, or 1/2. So to check your pattern, you're going to take your next term, which is 0, minus the previous term, which is 0.5, and you're going to get negative 0.5. Next one, negative 0.5 minus 0, I'm going to have negative 0.5. Last, negative 1 minus negative 0.5, again, two negatives make a positive. Negative 1 plus 0.5 makes negative 0.5. And you can check this with using your calculator if you need to. So the recursive formula says a sub 1. What is your first term in your sequence? Our first term in our sequence is 0.5. Then our a sub n formula would be a sub n minus 1 minus 0.5. Your previous term and your common difference. So how do we find our zero term? We're going to take our first term in our sequence, which is 0.5, and we're going to minus our common difference, which is negative 0.5. Two negatives make a positive, so 0.5 plus 0.5 equals 1. Let's look at our explicit. So a sub n equals a sub 1 plus, in parentheses, n minus 1 times d. So a sub n equals 0.5, because that's my first term in my sequence, plus, in parentheses, n minus 1 times my common difference, which is negative 0.5. So that's our multiplication. So now let's find the simplified version of that. So here we're going to simplify it. So a sub n would equal 0.5. Now I'm going to distribute. So my negative 0.5 times n would be negative 0.5n. And negative 0.5 times negative 1, a negative times a negative makes a positive 0.5. Combine your like terms. My like terms are my numbers, not with the variables. So a sub n, if I have 0.5 plus 0.5, I have 1 minus 0.5n. Again, this is my zero term, and this is my common difference. Okay, let's look at one more. So I have 2.6 to 2.9. I'm adding 0.3. 2.9 to 3.2, I'm adding 0.3. And 3.2 to 3.5, I'm adding 0.3. So my pattern is I'm adding 0.3. So to check it, you take your next term, which would be 2.9, minus your previous term, which is 2.6. So that's your second term minus your first term, and you would get 0.3. To check the next one, you would have 3.2 minus 2.9, so your third term minus your second term, which is 0.3. Then lastly, you would have your fourth term, which is 3.5, minus your next term, which is 3.2, and you would be left with 0.3. So a recursive function would say a sub 1. Your first term in your sequence is 2.6. A sub n equals a sub n minus 1, so your previous term plus your common difference, which is 0.3. Okay, let's find that zero term. So when n is equal to 0, you're going to take your first term, which is 2.6, minus your common difference, which is 0.3, and you get 2.3. Let's look at the explicit formula now. You would have a sub n equaling a sub 1 plus n minus 1 times d. So a sub n would equal 2.6 plus, in parentheses, n minus 1 times your common difference, which is 0.3. To find the simplified version, you're going to distribute your 0.3. So a sub n would equal your first term, which is 2.6. 0.3 times n would be plus 0.3n, and negative 1 times 0.3 would be negative 0.3. Combine your like terms, a sub n would equal 2.3 plus 0.3n. Again, this is your zero term, so that's when n is equal to 0, and this is your common difference.